The moon has still got a lot of secrets it's keeping.
There's still so many questions locked up in these rocks. It's exciting times just to be studying them.
This is the only long-term information that we have from the surface of the moon, are these data. There's just nothing else.
Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique, or at least unusual? What does it all mean?
I'm Katie Atkinson, and this is NASA Explorers Apollo, where we tell stories about our moon and the people who explore it.
Tape recorder's running, right? Tape recorder's running.
In the 1960s and 70s, 12 humans walked on the moon over the course of 6 Apollo missions. About 400,000 Americans worked behind the scenes to get them there. There were also millions of people around the world who listened, watched, and celebrated alongside them. They were all explorers. A quick note on why we're telling these stories right now. Over 60% of Americans living today, myself included, weren't born yet, or were too young to remember the first moon landings. They've never known a world where people couldn't walk on the moon.
Armstrong is on the moon. Neil Armstrong, 38-year-old American.
Now there's a new generation of explorers. Explorers who will witness the first woman walk on the moon and see the first human mission to Mars. Some of us might even help get them there. In the meantime, stories about where we've been connect us to where we're going. What we learn now and in the future builds on what we learned in the past, especially when it comes to understanding our moon. If you want to know what the moon looks like up close, Ernie Wright is the person to talk to. Even though he's never been there, he's visualized just about every nook and cranny on the lunar surface, sometimes down to a few feet. He's one of NASA's resident experts on moon data.
I work at the Scientific Visualization Studio at Goddard Space Flight Center. The studio uses data from NASA missions to create animations and illustrations that explain that data.
Data sonification is the sound equivalent of what Ernie does visually. A chart lets you see data. A sonification lets you hear it. You can listen to a data sonification over and over again and hear something new each time. Every instrument, every sound means something. It's music, and it's all based on data. What you're about to hear is a musical representation of lunar science past to present. What you'll hear in this sonification is the amount of scientific activity associated with the moon over time. Ernie will walk you through it.
The pitch of the melody is telling you sort of the amount of data that was returned about the moon over time. There are several instruments that are establishing tempo. There's a clock sound that tells you about the progress of the months. And there are symbols that go off to mark the times of launches. During the Apollo era, the pitch rises as we learn more and more about the moon and gather more data. And then there's this period in the middle where it kind of falls, when we weren't sending people and we weren't sending robotic missions. It falls off a little bit. And then it starts to rise again to a crescendo in the modern era. In the sonification, there are these two peaks in the valley, but the other thing to take from it is that there is a continuous note of exploration, that the sound doesn't really go away. The past and the present and the future are all connected, and you get that sense when you're listening to it that while there are variations in our level of interest and in the amount of data that we're gathering at any particular time, there's also a continuity that once we went there, we didn't want to stop. I think what motivates us to answer, the question of the moon's origin or how it formed is very basic, because once we understand how the moon was formed, we know a lot more about how the Earth was formed. We know about how the solar system was formed. It's all to do with this question of where did we come from? How did this happen? Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique or at least unusual? What does it all mean?
Answers to those big questions are within reach, thanks in part to modern-day exploration of our moon. The rising pitch at the end of that sonification, the crescendo, is a sign that we're learning. We're exploring more. We're driving the pitch up into the future. Before the Apollo missions, we knew almost nothing about the moon.
The state of our knowledge before Apollo was almost utter ignorance. We knew where it would be in the sky, but only approximately. We didn't even know if it was wet or dry. We didn't know what it was made of or how it related to the Earth, how it formed. We had no idea. We didn't know what the craters were, and there was really no way to know until we went there and sampled the surface and saw it up close.
During the Apollo era, we learned so much about the moon, but astronauts only visited a few spots.
If you were exploring the Earth and you landed in 6 places near the equator, you would know not a whole lot about the Earth. So even after Apollo, there was a great deal to learn, but we knew so much more. We knew the right questions to ask. And so one of the motivations for Lunar Reconnaissance Orbiter, I think, was to answer some of those questions, which had been lingering since the Apollo era.
The Lunar Reconnaissance Orbiter, or LRO, is a NASA spacecraft that's been orbiting our moon since 2009. LRO has mapped the moon like never before.
LRO is writing the Lunar Encyclopedia, the Lunar Atlas. It's the thing that you go to first to look up all kinds of information about the moon.
Thanks to LRO, we've learned so much more about our moon. In 2017, scientists discovered that there's frost, frozen water, at the moon's poles. We've also observed that the moon is shrinking over time, a result of it cooling since its formation billions of years ago. Our knowledge of the moon is now so much more nuanced than it was 50 years ago, but NASA never stops learning. That really comes across in the data sonification. Let's listen to it again, now that Ernie has broken down what each sound means.
But why, some say, the moon?
12, 11, 10, 9.
Why choose this as our goal?
Ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have liftoff. Liftoff at the
And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic?
all stations pressurized at this
Tower clear. 2,195 feet per second.
Why does Rice play Texas?
Okay, we just lost the platform, gang. I don't know what happened here. We had everything in the world dropped out.
We choose to go to the moon.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on course and puts Apollo 12 on the proper course.
We choose to go to the moon. the moon in this decade and do the other things, not because they are easy.
That's a good one. Looks like a very good one.
But because they are hard.
Okay, Houston, we've had a problem here. This is Houston, say again, please. Houston, we've had a problem.
Because that goal will serve to organize and measure the best of our energies and skills.
I'm going to step off the limb. It's one small step for man, one giant leap for mankind.
Because that challenge is one that we're willing to accept.
Okay, stand by there,
One we are unwilling to postpone.
Houston, Tranquility Base here. The Eagle has landed.
And one we intend to win.
That's a beautiful stadium. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here.
In that version of the sonification, you heard tape from the archives, like selections from JFK speaking and excerpts from Apollo mission audio. This kind of historical data helps us understand the full impact of our journey to the moon. Holly McIntyre agrees. She's a NASA archivist who believes that these stories remind us where we came from and inspire us to keep looking forward.
I think probably what I love most about being an archivist is just being able to capture the human experience within those records. So sometimes we have records that are very black and white. This is evidence of what happened. But my favorite part are the records that kind of tell more of the human experience. So maybe they're a memo from one specific person to another person, or maybe there's someone's personal photographs that they took, or maybe it's an oral history. Those are the types of records that really drive me, because I really just love to hear the human take on what happened.
So, in that spirit, we're asking you to help NASA tell the Apollo story. What do you remember about the first moon landing? Or what are you looking forward to as NASA prepares to return to the moon by 2024? So far, we've received hundreds of submissions from people all over the world. This first memory comes to us from France. Here's what Elena remembers.
Hello, NASA. I'm a retired American wildlife biologist living in France. I was 23 years old when the first people walked on the moon. I was living in Seattle, Washington, and working as a legal secretary. At that time, I was an avid fan of the Star Trek series on television, and I still am. I really wanted to see this historic event. I couldn't quite believe that it wasn't a national holiday. But it wasn't. So I called in sick at my law firm to be able to see it. At the time, I didn't have a television, so my boyfriend John and I had to go to a friend's house to watch it. The friend only had a small black and white TV, and he wasn't interested in watching it at all. It was just John and I. But we got to watch it, and it was thrilling. I'm a firm supporter of the space program, and I hope that we continue to peacefully explore the universe to learn more about life, the universe, and everything. Thank you, NASA, for the opportunity to share in this great celebration and anniversary.
Thank you, Elena, for sharing this story with us. We want you to send us your Apollo memory. Visit nasa.gov/Apollo stories to learn more.
Very good.
You helped design how astronauts would stay alive and comfortable while working on the moon.
Science is something you test, you experiment, you get results, and that modifies the way we look at the world.
Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique or at least unusual? What does it all mean?